Welcome to Eric's Guitar Amplifier Repair in California. My name is Eric. Today we have a Marshall JCM 800. This is model 2210 at 100 watts. Customer complaint for this particular amplifier is no output. Let's begin by doing a visual on the enclosure. Here we see heavy dirt and grime. Also, there are wax stains on top of the enclosure. Here's the view of the front of the enclosure. Again, wax stains on the lower left quadrant. The potentiometers were very stiff. The grease inside the potentiometers had dried up, so we fixed that with deoxit. Here is a view of the back of the enclosure, protective grille. You can see at the upper left and right quadrant we have only 2 screws securing the back plate. These are the improper screws. We'll replace that with proper brass wood screws. Here we see the direct out and the fixed loop. We have a sticker here that says Burbank Boulevard, Hollywood, California, my old stomping ground. Nice to see that sticker. Here we see the internal view of the backside chassis, all the preamp tubes. Chassis covered in a lot of filth, which we will clean out. Some rust as well. And there's the preamp tube with a nice thick layer of filth, but we will clean those as well. Output tubes and the old British LCR filter capacitors. These are rare. They no longer make or manufacture this particular capacitor, so these are very rare. They're good capacitors. They last a long time, and I really like these capacitors. They sound great. We see the 4 output tubes, 4. This will give you the 100 watts. So we're going to begin the test of the Electron tubes. I've just pulled out the very first tube. It's the ECC83. The top is pretty dirty, and we have rust on the tube's enclosure. Here we have rust at the top here, and we'll clean that up. We'll hit this with a little Windex, but I wanted to document the script on the tube. There's no other way to determine who's the manufacturer of this tube. I'm assuming that it's probably Softtech or one of the other manufacturers, and that's not a problem. What's important is that we test and that we clean the pins, so on and so forth. So we'll begin that. I'll show you the first test on this. I won't show every test of each tube. However, any tube that fails, I will record that. Let's begin. So we've cleaned the top of the Electron tube. We're going to turn on the tester and we will test the first preamp. And we're just going to let the filament warm up. And let's see if we have a go or no go on this tube, and it looks like it's testing strong, testing very strong. That's good. It's time to test the output tubes. This is an EL34 Mesa Engineering STR440 and 30 top here. We see this darkening on the glass tube, and we see that the getter is almost gone. I don't know if that's rust inside there or just dirt. Looks like rust. So this may be the life of the tube here. Let's run the test and see what we find. Let me go ahead and clean this. We've cleaned the Electron tube. Again, a little bit of getter at the top there. A better view of this sort of darkening. It doesn't necessarily mean anything. Let's see if there's life in this tube. For these larger output tubes, it takes a while for the filament to heat up. Let's see if there's enough time here, and we see that it's good. It's at the low end, but we're going to wait a little bit longer and test again. And you can see that it's moved up, so it's a good tube, and that's a good sign. This is output tube position V7, and unfortunately it is not passing test. It has been sitting on the test machine for a little bit too long, and I think it's time to replace this particular Electron tube. We have output tube V8, and again we're showing that it's the end of the life of this particular tube. Here is output tube V9, and you can see there's no longer any getter, and this might be showing that there's a vacuum leak, that there may be a crack somewhere here. We'll know when we do the test, so let's do that now. Usually when there's a crack in the glass enclosure, you get a sort of white at the top. We're just waiting for the filament to come on. I'm getting to see a little bit of the filament glowing. That's a good sign. Let's test, and as I suspected, it looks pretty dead. Let's give it a little bit longer to warm up. Well, maybe this one's going to pass. Let's give it a little bit longer. One more time. And this one looks like it should be replaced as well. I'd like to, let me see. Yeah, I think this is a good idea to replace this tube. It looks like it's about ready to fail. You know, once everything is put back together and you play for a couple hours and then you find that the volume drops out or you get noises, crackles and pops, this is usually due to a tube that's ready to fail. We're going into the green at this point, but yeah, maybe it's a good idea just to keep this tube as a backup and we'll replace the tube
should be testing much stronger than that. All right.
And now it's time to do a visual of the circuit board. The circuit board is done beautifully. Great workmanship by the assembler. All the wires are loomed nicely. I really like the workmanship done on this particular specimen. Now it's time to check the capacitance of the filter capacitors. And we will see here that the capacitance test passed for this particular can. Two capacitors within one can, and they both passed. Excellent. Here is a comparison of rust removal for the preamp cover. And we're now cleaning the preamp sockets. This is how I like to clean the output tube sockets with this little brush. And we'll go ahead and clean all of the sockets. The brand new EL34 output tubes. Awesome. Time to insert the output tube sockets. The tubes are keyed. Now we're going to place them in properly. Here we have a view of the brand new EL34 output tubes. Awesome. Now it's time to begin the procedure for biasing the new tubes. I'm going to show you where I place the digital voltmeter. And it goes on this portion of the resistor. This is R51. And we're going to bring up the amplifier slowly with a variac. We're going to keep an eye on the current, make sure that it doesn't spike, and we'll see that it goes fairly smoothly. I'm looking for a negative voltage between negative 38 volts VDC and negative 48 volts. It's a big range. I like to get it right at negative 40 volts for this particular model. That's 39 milliamps. And you'll see here at the factory setting it was set at 36. That's a little bit lower than I'd like to see, and it was cranked at the lowest end on the variable resistor 10-2 meter. And then In the next shots, you'll see just an adjustment of getting it up to 38, which is the minimum, negative 38 volts, and then finally settling in at negative 40. And here's a shot of the tool that I like to use to make the adjustment. And this is a tool that is enclosed in glass. This is a glass enclosed tool. Just a quick visual of reference, current, voltage, watts, so on and so forth. Amplifier has been on for approximately 25 minutes and we're just dialing in that negative 40 volts. You'll see me fussing with the potentiometer here, just trying to nail that negative 40. That's a sweet spot for me on this particular amp. And now we're ready to do the sine wave test on the oscilloscope. This is just to verify that everything is working properly, and we can see a nice clean sine wave. Excellent. Now it's time to contact the client and have them pick up the amplifier. Here we're showing the proper fastener. This is the replacement for this incorrect fastener. And there were only 2, and now we have 4. Excellent. Here's a shot of the enclosure now, cleaned and preserved. Removed as much of the wax that we saw in the previous beginning video as I could. The client was missing the foot switch, so I built them a hand-built foot switch. And now we're going to test the foot switch, making sure that everything is working properly. Fantastic, everything is working as it should. Excellent. So this is what the client will receive. They receive an analysis report, and this includes an image of the sine wave test. Any parts replacement is given to the client as well. This is just a shot of the old output tubes, and we always write bad if the tubes are bad. But everybody gets their parts back to make sure that they know we do quality work. Eric's Guitar Amplifier Repair, helping musicians to perform better.